So we did a router on a stick. We had a router connecting to a switch. In this switch, we had VLAN 10 member, VLAN 20 member, and the IP address on VLAN 10 is, let's say, 10.0.0.1, and the IP address on VLAN 20 is 20.0.0.1. And we know this is an access port. This is also an access port. What about this port? Will this be an access port or a trunk port in router on a stick? Trunk port. Why trunk? Because if I'm pinging from alpha to beta, traffic needs to go and then get routed and come back. So multiple VLAN traffic, VLAN 10 and 20. Even when when beta talks to alpha, it goes as 20 and comes out as 10. For that, this need to be a trunk port. All these things we saw in our previous class. This need to be a trunk, and if it is single interface, then we create sub interface. You remember sub interface? Ethernet 0.1, Ethernet 0.2, and we say this belongs to VLAN 10, and we put a gateway 10.0.0.10. Here we give 10.0.0.20. So this is how inter-VLAN routing can be done. Routing between two different broadcast domain members. Each VLAN is a broadcast domain. We are routing between two different broadcast domain members, VLAN 10 and VLAN 20. Now, there is some drawback in this. See, I'm not saying you should not use this method. Many are using this. But in a small scale environment, you can see this. Why I cannot use this in a large scale environment? See, in this example, you just got two computers in each broadcast domain, in each VLAN. But in the real world, in each VLAN, you will have many computers. Many will be talking to many other in the other VLAN. So all will try to use the same link and come down via the same link. This is going to be a bottleneck. Why? You just got two VLAN. If I have 200 VLAN, and in each VLAN, let's say you got 10 members, then you got 4,000 members. 4,000 member traffic going on this single link to get routed to another VLAN will cause a bottleneck. Do you understand why bottleneck? This link will be a bottleneck. Second reason why we should not use this in a large environment. If this link breaks, the routing between VLAN also breaks. Do you agree? So, yes, it's single link, wire can easily break anytime, if someone accidentally pulls the cable while walking, something like that. So there are chances for a wire to fail. Router won't fail, switch won't fail easily, but a cable may get failed. Some loose connection or something like that. So one small loose connection will cause loss of communication between VLANs. Second, okay, that's the second reason. So two reasons I have said. One is the link is a bottleneck in a large scale environment. Second reason is single link you got. If that single link fails, then the entire office will stop communicating to other VLAN members, which cannot be accepted, which is not an acceptable one. And the third reason is the space and the time taken. You see, the packet enters into the switch, get processed by the switch motherboard, CPU, RAM, etc. And then it understands that it needs to send the packet via the trunk link. It goes here. Again, it gets processed by the CPU here, check the routing table, and then the packet again comes back in the same path where it went. Again, it processes and then goes out. You see how many times the same packet getting processed here 2 times, here 1 time. Totally 3 times the packet needs to get processed in order to go from one VLAN to another, which is too bad. So what is the solution? What is the solution? Solution is multi-layer switch. What is multi-layer switch, Santosh? See, this is a layer 2 switch, which uses only MAC address to forward the packet. But multi-layer switches can work in layer 2 as well as layer 3. It is single box, single switch, but this can do both switching and routing. Those switches are called as multi-layer switches. So this is L2/L3. We call it as multi-layer switch. By default, it will be a layer 2 device by default. But you can enable the layer 3 feature in order to support layer 3 function routing. You understand? So by using this device, you see same function. I have 2 computers, one in VLAN 10, another one in VLAN 20, 10.0.0.1, 20.0.0.1. You see the packet enters. In the single processing, it will know that I need to send it here. Boom. Because it has got both layer 2 and layer 3 function, single time processing. You see there is no bottleneck scenario, There is no single link failure. And you see the space consumption is also less. Here you need to keep two devices, so more space is needed in the rack. This is just one device. And this also you need to maintain power supply. This also you need to maintain power supply. Here it is only one power supply. And to configure this, you need to log into a separate computer, the console. You need to log in here against the game. But for this, it is only one console. You understand the advantage of using multi-layer switch? So, using a layer 3 switch will increase the speed of your network instead of going for this router on a stick. A router on a stick versus multi-layer switch. Router on a stick, you got a single point failure, you got bottleneck, you need more power to run multiple devices, and the administrator job is more because he needs to jump between two different consoles. But if you see the multi-layer switch, it's just single box, so comparatively less power, less space, less cooling effect needed. In your room, if you have too many devices, then more power is consumed for the air conditioning. Here, you are reducing the number of devices to half. Earlier, you may have 50 devices, 25 router and 25 switch. Now you got only 25 multi-layer switch, only 25 so half of the devices have been reduced. So space consumption is reduced. CPU utilization is, the power consumption is reduced. Management becomes easy. No single point failure. No bottleneck. The only disadvantage of multi-layer switches, guess what? Guess what might be the disadvantage? Multi-layer switches got a lot of advantage. Now, what might be the disadvantage? The cost. The cost. Multi-layer switches are costly. Multi-layer switches are costly, but compared to this cost and this cost, let's say, for example, this is 10 rupees, this is 10 rupee. This is not 20 rupee, this is 15 rupee. Now you may say how it is costly. See, even though this is a multi-layer switch, when you do both layer 2 job and layer 3 job on a single device, that device will be more busier than these devices. This has got separate job to do. This will do only layer 3 job, this will do only layer 2 job. They are dedicatedly designed to do this job. But this one is like two men working, two men's work done by one person. He may be very strong, beam boy, but for a long run, if you see, employing two person is better than employing one beam boy. For a long run, employing two person is better than employing one beam boy. So what I'm trying to say is, this is precisely then designed to do routing. So this has got more feature, layer 3 features. This also got more layer 2 features. Whereas in this, you got layer 2 features, no problem, but less layer 3, less features supported, less layer 3 features. See, even though it can do routing, you cannot expect all that router will be done by this. All that a router does. For example, router can do MPLS, which we'll be learning later. Those MPLS are not supported in this. Yeah. So, but when it comes to IVR, inter-VLAN routing, this is the best solution, no doubt. This is best. Now, if you understand this, we need to go to the next level. Are you ready for the next level? What is that? You see, these computers need a gateway. What is the gateway for this? It is 10.0.0.10, isn't it? This router's address. What is the gateway of this computer? 20.0.0.10. The router's address, okay? One is the IP, router's address. Now, in a multi-layer switch, where will we assign this IP address? See, here you got a physical interface on the router. On a router, we have a physical interface. That physical interface we subdivided and we call it a sub-interface. And on the sub-interfaces, we have assigned these addresses. But where is that sub-interface in this? Or where is the interface for this VLANs? We need to create one virtually. For VLAN 10, I need to create one virtual interface for VLAN 10. For VLAN 20 also, I need to create one virtual interface. Virtually, you need to create. We call it as interface VLAN. I need to create one interface VLAN 10. Here I need to create another interface VLAN 20. To that interface, I'll give that IP address 10.0.0.10, 20.0.0.10. So to this PC, I'll give 10.0.0.10. And to this PC, I'll give 20.0.0.10. You understand? Shall we do this in the lab? So we have modified the previous class topology. I just removed the routers and switches, and I have placed a multi-layer switch. You see, it's named here, multi-layer switch. Now I'm going to go and create two VLANs. First, I'll create two VLANs. Host name, I'm going to give some name, Sam, and then VLAN 10, VLAN 20. Two VLANs I created. Show VLAN brief. I can see those two VLANs, but the allocation of interface needs to be done. Let's do it. What are the interface? Needs to be in VLAN 10. Can you tell me what are the interface? Tell me the interface name that needs to be in VLAN 10. Santosh, I'm unable to hear you. No. What is the interface name? F01 and What are the two interface? Ah, exactly. That's what I want. You see, config T interface, because you need to configure two interface with same configuration. You can use the command range. If it is single interface, don't put range. Okay. F0/1, comma F0/3. That's it. Right now you are inside this two interface. You understand? Now this port is an access port, isn't it? Switch port mode access. Why access? Why should I configure access? Why not trunk? Why? Because this interface belongs to a single VLAN, isn't it? VLAN 10. Ah. Switch port access VLAN 10. Next, interface range. What is the interface member of VLAN 20? Name it. Mm-hmm. F01. See, this is VLAN 20. This is VLAN 20. F0, 4. Yeah. So interface range F0/2 hyphen, sorry, not hyphen, comma F0/ use space F0/4. So I'm going to this two interface and saying switch port mode access, switch port access VLAN 20. Now, how do you verify this? Show VLAN brief, isn't it? You can see now 1 and 3 in VLAN 10, 2 and 4 in VLAN 20. Okay, now let us try pinging the VLAN 10 members. Say I'm going to this computer here. What is the IP address of the other VLAN 10 member? Santosh, are you there? Exactly. Will it ping? Will it ping? Yeah, it should ping. Correct, you are right. See, we are pinging from here to here. They are in same subnet. They are also in same broadcast domain. These two interfaces are in VLAN 10. So definitely this ping should happen. Traffic will come like this and come out like this. And it will go like this and it will go out like this because they are in same VLAN. Let's try pinging. See, you are able to ping. It is pinging. It is pinging. Likewise, from B to D also it will ping. Do you agree? Same VLAN and same network. Now, B ping 2000. What's the address of D? 2. I'm in B right now. I'm pinging D. As you say, it is pinging. Okay, it pings. So you're right. It pings. Now, but what we have done now is not inter VLAN, isn't it? It is within the VLAN. It is not between the VLAN. Now, doing inter VLAN, if you try pinging now, it won't ping. It won't ping because We don't have a router. To go from one network to another network, you need a router. And router needs interface. And interface needs IP, which will be the gateway. We need to create those things. See, right now, this is, even though it's a multi-layer, but the layer 3 feature is not enabled. Let me show you. Show IP route. See, there is no routing table because by default it is only layer 2. So how to enable layer 3? Listen, this is the command. IP routing. Okay. How simple you see. By putting this command, you enable the layer 3 feature. By default, it will have only layer 2 features. By putting this command, you add layer 3 features, meaning this switch now becomes a multi-layer switch. Now it can do both routing as well as switching. You see, is the switching happening? If you ping, you will see. If you ping your same VLAN members, you will be able to ping. It's switching. It is using the MAC address to move the packet. Now, because I have enabled the feature routing, IP routing, see earlier before typing that command, your routing table was not shown. But now if you see, you got something more here. Earlier, which was this paragraph, this entire paragraph was not there. You see, it was not there. All these are routing protocols. These are all routing protocols. EIGRP, IGRP, routing information protocol, BGP. Earlier, it was not supporting routing, but after typing IP routing, it started supporting this routing feature. So it's a router also now. Now SAM is a switch as well as a router. See, it has got the MAC table also. Show MAC address table. It has got MAC table, so it's a switch. It also got a routing table. It's a router. But router needs interface, no? So we need to create a virtual interface. I told you, we need to create a virtual interface. I need to create this too. This virtual interface called interface VLAN has got a special name called SVI. What does SVI stands for? SVI stands for switched virtual interface. Switched virtual interface, SVI. So I need to create SVI, which is nothing but interface VLAN for VLAN 10, and assign this IP address. Another SVI, assign this IP address. It's a layer 3 interface. Shall we create now? Before creating, I want to show you. Show IP interface brief. You don't see any interface named VLAN 10. Do you see any interface named VLAN 10 or VLAN 20? No. You have VLAN 1 that is default, that is also down, never mind. But we are focusing on VLAN 10 and 20. This is what called as SVI or interface VLAN. Now let us create VLAN 10. Interface VLAN 10. It gets created, you see. Immediately it gets created. You want to go check? Let's check. Show interface brief. You see here VLAN 10 has come. And it is up. Now let's create VLAN 20. VLAN 20. Now, interface VLAN 20. It is interface VLAN. It's a layer 3 interface. Let us check again. Now I'm going to assign IP address here, which will be used by the computer as a gateway. You remember, we used to create that on the router side. We used to create on the router side. Now we are going to create inside itself. So let us go and give IP address. Interface VLAN 10. IP address is 10.10.10, sorry, 10.0.0.10, 255.0.0. That's it. Likewise, interface VLAN 20. IP address is 20.0.0.10. Now, let us verify. Show interface brief. You see here. Now, if you check the routing table, you will see routes. What is the command to check the routing table? You see, earlier we did not have this route. It is pointing towards the virtual interface SVI that we created. SVI means what? Switched virtual interface. SVI means what? Interface VLAN. Now this router says, I know VLAN 10, I know VLAN 20. Now let us go here and try pinging other VLAN members. Earlier, when I was pinging 20, it was not pinging. But now, it will ping. First time 1 or 2 packets will get lost. Okay, it started pinging, you see. Now if you try pinging again, it will give 100%. No loss. Yeah. Now let's ping 20.2. You see? Now let us trace route and see. This is the spelling. TRACER. Trace route 20002. It won't go directly, it will go to the gateway. Correct, no? It goes to the router interface. Even though it's not a physical one, it's a virtual one. It goes to the router interface. And then it goes to the final 20 network, VLAN 20. From VLAN 10, without going to the SVI, without going to the router interface, you cannot get routed to other VLAN member. Is this clear? It's the same output you got with many switches and router on a stick. But here you see only one switch. You're able to achieve same thing what you have in the router on a stick. See, I want you to spend some time, think, and ask me doubt. I'll wait. Single time processing, not 3 times processing, single time. So this is going to be more faster than the router on a stick method. So have you done VTP lab? STP, VTP, and then port channel on mode, LACP mode, PAGP mode. I want you to do this immediately, if possible now, or otherwise